Okay, this is interesting. We know that the number 1 is called the identity element for multiplication of real numbers. If we multiply any number by the identity 1, it just gives us the same number that we started with. Here's an example. 1 times 8 equals 8. 8 times 1 equals 8. It doesn't change 8 at all when we multiply by the identity 1. Now let's see if this happens when we do it with matrices. We just learned from the previous note that the identity matrix, let's say for a 2 by 2 matrix, the identity matrix is the matrix that we have written here. 1 down below 0, 0 down below 1. In other words, there's 1s on the diagonal and 0 everywhere else. We're going to try multiplying that by a second 2 by 2 matrix. 3 down below 5 and 4 down below 6, and see if it does what we expect it to do. Will it just give us the second matrix back again? Well, let's try. Solution. It's equal to, now remember how we do this. First, we know that the entries are going to match. The inner entries are going to match. They're both 2, and the outer entries are a 2 by 2. That means that we're going to have a 2 by 2 solution. Let's go ahead and distribute multiplication from this side, which is 1, 0. That's the first row, down the first column. And we'll put that in our answer in this position. So 1 times 3 is 3, plus 0 times 5 is 0. And then we'll do that again with the second column and put the answer here. That's 1 times 4 is 4, plus 0 times 6 is 0. Now let's go downstairs to this second row and put our entries here and here. 0 times 3 is 0, plus 1 times 5 is 5. And now the last column, 0 times 4 is 0, plus 1 times 6 is 6. We'll simplify, and our answer is 3 down below 5, 4 down below 6, which is exactly what we started with. That's our answer. We'll put a box around it, but what I want you to notice is when we multiplied that matrix, 3 down below 5, 4 down below 6, by the identity matrix, it changed nothing. Let's do it again with the identity matrix on the right side. Here we go. Again, we're going to get a 2 by 2 matrix, so we'll put our entries here, here, and then down below. Then we'll simplify. Okay, so we go first row across first column. 1 times 3 is 3, plus 4 times 0 is 0. First row, second column. 3 times 0 is 0, plus 4 times 1 is 4. Down below, second row, first column. 5 times 1 is 5, plus 6 times 0 is 0. And finally, the second column, 5 times 0 is 0, plus 6 times 1 is 6. Simplified, that is 3 down below 5, 4 down below 6, which is exactly the matrix that we started with when we multiplied by the identity. And we've demonstrated what we wanted to show. It tells us that when we multiply a 2 by 2 matrix by the 2 by 2 identity, it changes nothing. And we can generalize that and say if we multiply any square matrix, square means it has the same number of rows as columns, n by n matrix by the identity matrix for an n by n, whether you do it multiply by the identity on the right side or the left side of the matrix, you're not going to change the value of that original matrix.